Hey everyone, today we're going to go over two very important computer science fundamental concepts, conditionals and loops. These are used in almost every single programming language and make your whole life more easy and your programs more interesting. So before doing that, we're going to go over a review problem, right? So we're going to write a program that takes in your friend's first and last names as input and it'll return the full name. You'll take the first and last name as separate inputs instead of one input, so we can practice this whole concept of input, right? So when first take our first name, string first equals in dot next line, and last name, we'll do the exact same thing, and we'll prompt them as well in between. What is your first name? Right? And we'll do this exact same thing again for your last name, and then basically print out the concatenation of them both. Concatenation is a fancy word for just saying when you're combining two things together and putting the beginning of the second one behind the first one. So now we're going to print out the first and last name together. We can't run the program like that normally, so we're gonna have to compile it right now in the terminal. It's built into Virtual Studio Code. It might be in other IDEs as well, and you can also go to command prompt or terminal or whatever command line interface you have on your own device. So now we're going to run this program, and it'll ask for us for our first name. I'm going to put John, most generic name, Smith, another generic last name. So I'm going to print out John Smith as their first and last name combined together, concatenated together, right? Now we are going to actually start conditionals. So conditionals allow you to incorporate logic into your program. So if you want to test a condition like, is your age greater than 18? And if this is true, then you could like do something. You can run certain lines of code like print out something, or like suppose we have let's use watching a movie in a movie theater as a case study, right? So if you're old enough, if you're above 18 years old, you can enter movie theater. Otherwise, you can't. To program like a robot that will do that for you, what you do is if age is greater than 18, I'll let them in. Else, like if they're under 18, don't let them in, right? So conditionals allow us to have this sort of logic to our program, like do certain lines of code if a certain condition is passed, right? Loops is what also makes computers like really powerful. Like they can do like stuff we can, right? But they could do it really fast. So like they could do hundreds of like millions of operations a second, and you could do like programs like print my name 100 times, and it'll just do it for you in like less than a second, right? So syntax for the conditionals are as follows. So we use something called if statements. So in an if statement, what you do is you write if, and within the parentheses that follow the if, you put your condition. This condition has to be a Boolean value because you can either pass a condition or you could fail a condition. There's no like middle ground, right? So if it's true, that means you passed the condition, and if it's false, that means you failed the condition. Like suppose you could put something like is age greater than 18? If it's true, then you entered this block inside, and you also have to put all the code for that if block within these braces. So what goes inside, right? So if you pass a certain condition and you want to write some code that will follow like the past state of that condition, then you'd put that inside here. And if it fails, you would follow it. You would follow it in the else if or else block. So the whole logic pathway is as follows. So if you pass a certain condition here, you will execute these lines of code. And if it fails, you go to the next condition and test that. And if this fails, you'll keep going on and on and on. So if is your first initial condition that you can test, you can have as many if statements as you like. And else ifs, they always have to be followed by another else if or a giant if or an if statement, right? So if a condition is passed, do it. If it's failed, like try another condition. And you can keep attaching else ifs, trying multiple conditions, and then else will just control every single other possibility. Like if none of the above conditions are passed, then it'll just do this. So this is optional. This is optional as well. You don't even need to have an else if. You could just have an if and an else, which is really popular. Many people do that. But yeah, this is the general format for conditions, and I'll do it while we do this practice problem. So we're going to make a program to identify whether an integer is even or odd. We'll print true if it's even and false if odd. We did this program earlier, but we didn't use if-else statements, and we'll do that right now. So we don't need this. So we're first, the program is on, the prompt is on line 10. So now we can start. So we're going to get an integer from the user, int x equals in.next int, right? Now we're going to begin our algorithm. So if x mod 2 equal to 0, I say equal, but that basically means testing if the value is like equivalent on left and right hand side. So if this is true, then that means it's even. So we're going to print out true. We could print anything, but the prompt asked to print out true. So else, if this condition is not met, we're going to print out false because it failed, right? So the user inputs their number, and we test whether it's equal to 0. What is the modulus of that number when divided by 2 is equal to 0? That basically means it's even. We explained in our last video, so you can check that out if you don't understand that. So if this is true, then it'll print out true. If it's false, it'll print out false. You can print out anything with the prompt asks to print out true or false. You can put like yes, whatever. And you can have multiple lines of code here, like if do something here, do something here, right? And then you can also have else if statements, right? Maybe if you want to test another condition in between, like maybe if this is even, then print out true. Else if it's greater than 5, that means it's odd, and greater than 5, do something else. Maybe some random thing here, right? And if it's less than 5 and it's odd, then do whatever's in this block. So it'll keep testing the above conditions. It'll go in linear order, so it'll test this, then this, and then everything until else. And then as soon as the condition is passed, it will execute that, right? So you can't have any else ifs following else. You can have ifs, but they won't be part of the same block, you know? So yeah. Now let's test this program. We're testing if it's even or odd. So we're gonna file it java c day4.java java day4. So let's give a number 7. 7 is not divisible by 2, so it's false. Right now, let's do another program. Like we'll check whether a user is tall enough to enter a roller coaster. So let's go step by step. So we're going to enter their age as an input, right? So int age equals the next inputted age from the user, and then we are going to test if their age is this is a tall. All right, never mind. Not age, I guess. Height. My bad. Int height is equal to, we're going to get the height as an input, right? And we'll see if their height is less than 4, then we're going to print out 2 short. And if it's greater than 8, we'll print out 2 tall. And if none of those conditions are passed, then it's going to be, then they're fine. They can enter the roller coaster, right? Oops, that got deleted. Second condition is testing whether they're too tall. So we're going to give a certain height to the program, and then it's going to test whether or not the person can enter the roller coaster or not. Right? If it's less than 4, it will do this. If it's greater than 8, it will do that. And if none of those conditions are met, it will do this. Pretty straightforward. So we're going to give a height like 7. Welcome, because 7 is less than 8 and it's greater than 4, so it didn't pass the first 2 conditions. So I immediately went to the third condition, which contained all other possibilities. We'll run it again. We'll give it 10 this time. You're too tall because 10 is greater than 8. Right? So that's what basically the concept of conditionals. Right, so yeah, we just went over this. So if the um, the modulus of the number is equal to 0, like when you mod it with 2, then that means it's even and you print out true. Otherwise, you print out false. You can use else or test other condition when the mod is equal to 1, which means it's odd. So with loops, we can basically write a bunch of like instead of writing like suppose you wanted to print the first 100 numbers, right? Instead of writing like doing something out the print line and every single number within the first 100, you could just use a loop to do this in 3 lines instead of 100, right? We're not doing that, so we're gonna use a loop, right? So there are 2 types of loops: for loops and while loops. So for loops allow us to are mostly used for counting, like when you have a certain number of iterations you want to do. Like iterations means the number of times you want to loop. While loops are more for like keep looping until a condition is met. Like they'll keep doing a certain process until like an external factor says, okay, stop now, right? But both can be used for almost anything. They're almost the same, but there's like small differences that make one kind of that make some like one of them better for different applications, right? So the for loop allows you to do a certain code a certain number of times, right? So you could set so if you want to like sum all the numbers from 1 to 5, what you do is create a variable called sum, and we'll start adding numbers to that. So what we're gonna do is have a variable called sum, and then we're gonna do this for loop. So as you can see, the if is kind of similar in format. You have if and then parentheses, but in the for loop, we have 3 fields separated by semicolons. So in the first one, we'll go over to this. I'll go over more deep in a bit, but the whole idea is we're first going to initialize a counter in the beginning. We'll test if it passes a condition, and then we're going to keep getting closer to this condition. So we created a counter called num, set it equal to 1. Then we added num to sum. So we just like added whatever number was currently in number. Since num was 1, we added 1 to sum, and we incremented a num by 1, and then we went and added it back to the num. So now we'll keep doing this, right? I'll go over this in a second. So here's the whole breakdown of the for loop. So we initialize a variable to count, or like basically to basically go through our giant for loop. Like we want to loop over separate different numbers. So this is our way of going through them. So we initialize our first number, our counter, to 1, and then we'll check if it passes a certain condition. We'll execute the code in the for loop, and then increment the counter. So if we set our counter to 1, we're gonna check if it's 1 less than 100. Since that is true, we're gonna continue to our actual body of the for loop. Here's the part where we can this part is the code that's repeating. So now in this code, in this program, we're just printing out I like 50 times, right? So I starts off as 1, then it goes to 3, then it goes to 5, then it goes to 7, then it goes to 9, all the way to 99, right? Because 99 is the next number that's less than 100. So the whole process is you initialize this counter at 1, test if it's less than 100, do whatever we want, and then we increment the counter so we can approach this final ending point of our program, right? And we can have any part of the body inside here. So we'll do a quick program with that real quick. So if we want to print out, yep, here we go. I'll remove this. And if we want to print out the first 100 numbers, all we have to do is this. So for int I, like any counter, you could call it like CNT for counter. Like convention is to use I for counting. It's not a very good convention because you don't know what I means, but it's a popular one. So we're going to do I less than or equal to 100. We'll start off with 1. I'll explain why we're doing this in a sec if you didn't get it earlier. Don't worry about it. It's more complex than the while loop. So if you get this, you'll be able to get while loops easily, right? So we initialize our counter to 1, right? And then we're going to keep the next thing we do is after we do this first part, we initialize a counter variable. And then we're going to check whether it passes the test. If is I less than 100, yes it is, we're going to print it out. And we're going to increment I by 1, now I is 2. So this is only run once, we do this in the beginning, and then we just keep going between these three. We do this, then this, then this, then this, then this, then this, then this. We keep going in that cycle, right? So now that we have this program, let's test it. So Java C day4.java, Java day4. Right, so we print out the first 100 numbers. So 1 to 3 all the way to 100. So we initialize this counter to 1, test is less than 100, and then we increment it. So at the very end, let's go to the very end case. So suppose we're at 99, right? So we've gone from 1, we kept printing out I 98 times, and now we went up by 1, now we're at 99, right? So is 99 less than 100? Less than or equal to 100? Yes, it is. We print out 99, we increment 99 by 1, now we're at 100. 100 is less than or equal to 100, this Boolean value, this Boolean case in the middle. Since that is true, we print out 100. Then we boost up 100, like the increment 100 by 1 to get 101. We test whether 101 is less than or equal to 100. Since this case is false, then that means we exit the program. Like we not the program, we exit the for loop. So this is the time that this is the case that allows us to either stay in or leave the for loop. Right? So after 100, we're no longer less than or equal to 100, so we get out of the for loop. And then we can no longer access this integer I. It's a concept that we'll go over in the intermediate class called scope, right? So that's the for loop. The next problem is to print out the first 25 perfect squares backwards. So perfect squares are basically a number multiplied by itself, right? So if you want to start off the first 25, right, backwards. So what this means is that we're going to start our I to 25, right? And then keep looping while I is greater than or equal to 1, right? Because 25 to 1 is 25 iterations, and we're going to print out I times I, which is basically the perfect square of I, of like a number. So if you multiply I by itself, you get the perfect square of it. And then, yeah, so we're going to run this real quick. Java C day4.java, Java day4. So we print out 25 squared, then 24 squared, 23 squared, all the way to 1 squared, which is 1. That's the solution to the second part of the problem. And now let's do for loops. For loops are really while loops. While loops are really similar to for loops, except that we don't really, there's only one field in the middle. While loops are basically like repetitive if statements, but like in if statements, what happens is you do if a condition is met, this condition is met, continue, and if it's not, just like leave and check the next thing, right? While loops are similar in that once a condition is met, then what's going to happen is that it will go through the part like inside the braces, and then it's going to go back out and then repeat the whole statement again while the condition is met. So we set a count variable to 0, and then we're just going to basically increment count and then divide num by 2, right? So it's going to keep testing this. Oh, we never initialized num, but imagine it was initialized earlier, right? But the whole idea is we're going to test whether a condition is met, and if it's met, we're going to keep continuing this while loop until this condition is false, right? So we'll do that problem again with while loop, right? So print out the oh yeah, it's over here in the slide too, so you can look at that as well. So you just basically keep looping until a certain condition is met, and yep, I think that's how it was deleted. Here we go. If one is while loop for the first problem, what the whole syntax is this. So we're going to do this. We're going to set our variable outside, our counting variable outside, int I equals 1, and we're going to keep like while I is less than 100, less than or equal to 100, we're going to keep incrementing it, right, and then printing it out. So you have to make sure you're getting close to ending the while loop, otherwise it'll go on forever. I mean forever until you exit the program. So we're going to keep printing out I, and then we're going to increment I by 1. Right, so we created a variable here that as a counter for our while loop, and then while I is less than 100, we're going to keep doing this. We're going to print out I, increment I, check whether it's less than 100, and then do it again. So now the first step is, we can just run it like this, right? So it did the program successfully. So the whole idea is that we have a counter here. If I is 1 less than 100, yes it is. We print out 1. Increment 1 by 1, we get 2. 2 less than 100, yes it is. We're going to print out 2. Increment 2 by 1, we get 3. Do 3, then we're at like 99, right? At the very end of this whole process. Is 99 less than 100? Less than or equal to 100? Yes it is. Print out 99, increment it by 1, we're at 100. 100 is less than or equal to 100, we print 100. 101 is not, so we end it there. So then that's why we don't print on 101 to like infinity. That's why we ended 100. So this is basically for loops and while loops. Basically allow you to just do a bunch of operations in a really short amount of time. Makes the computers better, in quotes, than humans in that sense. We also covered conditionals, which allow us to add logic to our program. You can put if statements inside while loops or loops, and allows you to run certain segments of code in, instead of like running everything. So you can add logic in that way. So thanks for watching. Hope you understood everything. If you have any questions, feel free to contact us at Hackathon for Kids. Visit our website, hackathonforkids.com. Sign our general interest form if you want to join our sessions, and we can go over these concepts in depth. And otherwise, have a great day. And